Hello everyone, this is Anand Goud, Assistant Professor, Civil Engineering Department from Institute of Aeronautical Engineering. In this lecture, we are going to discuss about the topic linear measurement techniques. So after the end of this course, students will be able to apply the surveying principles. Like we are going to learn the details about the linear measurement techniques, and we can use those particular techniques for completing chain surveying, leveling, and contouring for accurate data collection. So coming to the contents of this lecture, in this lecture we are going to discuss about the linear measurement techniques and instruments used in chaining. Now we will discuss about the linear measurement techniques. So coming to the introduction part of this linear measurement techniques, see, this is the process of measuring distances between the 2 points on the Earth's surface. So linear measurements is nothing but we are going to measure the distance between the 2 points which are placed on the surface of the Earth. So these are linear. Okay. Next, it is one of the fundamental tasks in surveying, providing the necessary data for mapping, construction, and engineering projects. So linear measurement is one of the basic things we are going to use for surveying while measuring the distances, okay, from different point to different points. And because of this particular linear measurement techniques, we are going to provide the data required for mapping of the areas and construction of the buildings as well as engineering projects. Now, precise linear measurements ensure the accuracy of surveys, which is critical for the success of any project. So these linear measurements, whenever we are going to measure the distances linearly, the data should be accurate, and that is going to give accurate results. And this is one of the major issues we are facing in the surveying. Coming to the methods of linear measurement, here we have three types of linear measurements. The first one is direct measurement, okay, and the second one is measurements by optical means, and the third one is electromagnetic methods. Now we will discuss about these three methods in detail. Coming to the first one, direct measurements. Okay, in this we have different types of methods for doing the linear measurements, that is direct methods. The first one is pacing, second one is measurement with passometer, and third one is measurement with pedometer, and fourth one is measurement by odometer and speedometer, and chaining. So these are the different methods we are using in the measurement of linear dimensions in direct methods. Coming to the first one, pacing. So it is a simplest form of linear measurements where the surveyor measures the distance by counting the number of steps taken. So here, suppose for example, here you have point A, and we are going to measure the distance up to a point B. So if you want to measure a distance between these 2 points, we are going to walk through this particular distance. Okay, we are going to count the steps by the surveyor. Okay, how many steps you are going to play or take for walking from here to here. So by measuring the number of steps, we are going to do the surveying, that is called as a pacing. So here, before doing the pacing, we have to know the average length of the each step or else each pace. Okay, if you know the average length of this particular each pace, then you can count this number of paces by walking around that particular length, and this is called as a linear measurements, that is pacing. Okay, the length of one pace must be known. So before starting your surveying by pacing, you have to know the average length of the step or pace. So in this method, the number of paces between the 2 points of the line is counted. So here, suppose from point A to point B you are walking. Okay, now we are going to measure the number of paces you have taken. Okay, and then knowing the average length of the pace helps to know the length of the line. So if you know the average length, okay, what is the average length you are going to take for one pace? If you know that, then suppose here we have 1, 2, 3, 4, 5 paces. Okay, we have total 5 paces here, and if you know the average length, then you are going to suppose the average length of the pace is, suppose assume it as x. Okay, then now if you multiply with the number of paces and x, then that is going to give the distance in meters or millimeters depending upon the measurement. Okay, this is how we are going to calculate the distance between the 2 points by using the pacing. Okay. And next one, the length of the pace. The length of the pace is dependent on the person who is measuring. So depending upon the person, the length of the pace differs, because some different people will take a different lengths for one step. Okay, and the ground, okay, how the ground is, and the speed of pacing, and the slope of the country. Okay, depending upon these all factors, the length of the pace will be dependent. Next one, next type of method in the direct methods is measurement with passometer. Okay, measurement with passometer. So the passometer is a watch-like instrument that is carried on the person's packet or tied on the man's leg. Okay, so if you see this picture, you can see the passometer here. This is one of the instrument which is used to measure the distances. So this will be tied on the leg of the man's, or else you can keep this particular instrument in the pocket also. Okay, and the instrument records the paces when the man moves from one point to another point. So if you are going to move from point A to point B, then it is going to measure the number of steps or number of paces taken by the man. Okay, that will be recorded in this particular passometer. Next one, this technique hence overcomes the monotony and strain in counting the paces by the surveyor. So in the earlier pace, okay, in the earlier method of measurement, we are doing the pacing, right? We have to calculate, or else we have to remember the number of paces taken by the person or surveyor, right? So now here, no need to remember those particular paces. Automatically, this instrument is going to record the number of paces. So that is the benefit of using this passometer. Next, the distance is calculated as the product of the number of paces and the average length of the pace. Okay, same as in a pacing. Here we are going to note down the number of paces, and if you know the average pacing length, then you can multiply with that particular numbers, and then you will get the distance between the 2 points. Next instrument is pedometer. So pedometer is similar device like passometer that automatically measures the distance. So it is also same like passometer. It is also going to measure the distances between the 2 points. A pedometer is best in measuring the vertical distances. Compared to the passometer, this pedometer is benefit, or else it is having some advantage in measuring the vertical distances. So here you can see the pedometer. And next one, odometer. So odometer is an instrument that measures the number of revolutions. Okay, it is going to measure the number of revolutions of a wheel. So in this picture, if you see here, you can see one wheel type instrument. So this is the instrument we are going to use for surveying to measure the distances from one point to another point. So here, when you move this particular wheel, so it is going to record the number of revolutions in this particular device. Okay, and the number of rotations is multiplied by the circumference of the wheel. So after measuring after moving the wheel, okay, odometer wheel from point A to point B, if you move the wheel like this, so it is going to take some revolutions around this particular distances, right? So after reaching the point B, you just have to note down the number of revolutions taken by the particular wheel, and that particular distance will be calculated by multiplying the number of revolutions with the circumference of the wheel. Okay, we are going to measure the distance by multiplying with the circumference and number of revolutions. Okay, next one, this instrument does not provide accurate results on an undulating surface. So if the surface is not flat, then this particular instrument, that is odometer wheel, is not going to give accurate results. Okay, you may get some errors in the measurements. So when the surface is smooth, okay, we can use speedometer for measuring the distances. Next type of method is chaining. So chaining method determines the distance by means of a tape or chain. So in this also we are going to measure the distances from between 2 points. okay, by placing the chain or by placing the tape. Okay, this is one of the accurate methods to determine the linear measurements. So by using this particular chaining, we are going to get the accurate results compared to other types of methods in the direct methods. So the chain is used for ordinary precision. So in this, in the chaining, we are going to use tape and chain, right? So the chain is used for ordinary precision. That means here the precision will be somewhat less than the tape. Okay, the tape or special bar is used to measure a distance with high precision. So if you compare with the chain and the tape, the precision in the tape measurement is very high compared to chain. Now, measurements by optical means. So in this method, observations are taken through a telescope and calculations are done for distances such as tachometer or in triangulation. Okay, this is one of the indirect methods. So here we are going to take the observations through telescope and we are going to calculate the distances or dimensions by using the tachometer or triangulation method on the paper. Okay, this is about the method measurement by optical means. And third one is electromagnetic methods. In this case, the electronic methods and the distances are measured with the instruments that are based on the propagation and reflection and subsequent reception of either radio or light waves. Okay, by using this particular wave reflection and propagation, we are going to measure the distances by using the electromagnetic methods. One of the instruments we are going to use is total station. Okay, these are the different types of methods used in the chains, direct methods for measuring the linear dimensions. Now coming to the next part of our lecture, instruments used in chaining. Okay, in the chaining, we are going to use different types of instrument, okay, to measure the distances from one point to another point. See, the several equipment used in the chain surveying are chain. The first element is a chain, and the next instrument is arrows and pegs and ranging rods and offset rods, laths and plumb bob and cross tar. Okay, these are the different instruments we are using in the chaining. The first equipment is here chain. Okay, in this picture you can see the chain. Okay, chains are utilized to measure the horizontal distances. So the major benefit or usage of the chains are we are going to measure the horizontal distances from one point to another point. Okay, and chains are created of straight links of galvanized mild steel wire named links. So if you see the chain link, okay, this is straight link which is prepared with the galvanized iron. Now here you can see one of the examples of chains. See, the ends of each link are bent into a looped hand connected using three oval rings. So if you see this particular link, okay, this from here to here it is called as a link. Okay, and each link is connected with the looped rings. Okay, these are the rings, okay, which afford flexibility to the chain. Okay, these particular rings are going to make the chain flexible, that is useful for measuring and carrying. Okay, the ends of the chain are given brass handles for dragging the chain on the ground. Okay, the end of chain, suppose if you take the left end of the chain, this is one of the brass handle. By using this brass handle, we are going to drag the chain on the ground, okay, for measuring or for placing the chain properly aligned. Okay, and next one, the length of the chain is assessed from the outside of the handle to the outside of the additional. So the length of the chain is carried from the outside of the handle to the another outside handle. Okay, that is what the length of the chain. Next, the length of link is the distance between the centers of the two consecutive intermediate rings. Okay, so the length of the link is nothing but here you can see the length is represented from here to here. Okay, this portion is called as the link. See, the center of the ring to the center of this particular ring. Okay, that is what they called as the length of the link. Okay, and the end link contains handles. Okay, this end link is going to contain the handles. Okay, this is the end link and it is going to have the handle, and on the other side also we will be having one end link, and it is also going to carry one handle, which is used for dragging the chain or for placing the chain in a alignment. Next one, different chains used in the survey. Okay, see, in the chain surveying we are going to use different types of chains. The first one is depending upon the length. Okay, depending upon the length we are going to divide the chains into different types. The first one is metric chain. Okay, and metric chains are the most commonly utilized chain in India. Okay, in India we are going to use mostly the metric chain, and these types of chains comes in various lengths such as 5 meters, 10 meters, 20 meters and 30 meters. Okay, and the most commonly used chain is 20 meters chain. Next, tallies are given at every 2 meters of the chain for quick reading. Okay, so for every some 2 meters like this, okay, this is called as a tally and this is called as a tally. Okay, these are the tallies which are placed at a particular certain distance depending upon the chain length. Okay, and every link of this type of chain is 0.2 meters. Suppose if you take 20 meters chain, every link is going to have 0.2 meters length. Okay, and the total length of the chain is noted on the brass handle at the ends. Okay, at the end of this particular handle, you are going to have the total length of the chain. If it is 20 meters length, then it will be marked on the brass handle at the end. And next type of chain is Gunter's chain. Okay, the Gunter's chain is of 66 feet length. Okay, and contains 100 links. Okay, the total length of the Gunter's chain is around 66 feet. Okay, the length of this particular chain is 66 feet, and it is going to have 100 links. Such type of links are 100 are available in the Gunter chain, and each link is of 0.66 feet. Suppose if you measure the distance of length of this particular link, okay, this is around 0.66 feet. Okay, and if you measure that particular distance in inches, then it is 7.92 inches. And next, it was originally obtained for comfort in land measurement. Okay, since 10 square chains are equal to 1 acre. So originally this particular Gunter's chain is used for measurement of land because the 10 square chains are equal to the 1 acre. Okay, 1 acre will be covered by using 10 square chains. Okay, also while measuring the linear measurement. Okay, for measuring linear dimensions also we are going to use, or else for measuring the lands also we can use this particular Gunter's chain. The next one, 10 Gunter's chain is equals to 201.17 meters. So if you combine the 10 Gunter's chain, then that will be around 201.17 meters. Okay, and if you take 80 Gunter's chain, then that is around 1609.36 meters. Okay, these are the lengths of Gunter's chain. Next one, engineer's chain. An engineer's chain is 100 feet length and consists of 100 links. Okay, the total length of the engineer's chain is 100 feet and it consists of around 100 links, and each link is being 1 feet long. Okay, automatically you can tell that each link is going to have 1 feet length. And in this type of chain surveying, a brass tag is attached at every 10 links. So after every 10 links, we are going to have the brass tag, and that is going to represent some length with notches on the tags. So we will be having notches on the tags for every 10 meters or else every 10 links. Okay, that represents the uniform dimensions of the particular chain. Okay, that are demonstrating the 10 link segments number of between tags and end of the chain. And next one, the usages of engineer's chain are mainly measured to feet. Okay, mainly we are going to measure the distances in feet. Now coming to the next type of chain, revenue type of chain. Okay, the revenue chain is 33 feet length and contains 10 links. Okay, the total length of the revenue chain is 33 feet, and each particular revenue chain is going to have 10 links. Okay, and contains 10 links. Each link is 2 feet. Okay, each link will be having around 2 feet. 0.75 inches long. Okay, each link is going to have 2 feet 0.75 inches long, and the chain in surveying is utilized for measuring fields in cadastral areas. Okay, this particular revenue chain is used for measuring the dimensions in cadastral areas. That means for marking the dimensions of properties or any boundaries, property boundaries, we are going to use this particular revenue type of chain. Next one, steel band or band chain. Okay, these types of chains comes up with a steel small band strip of the same width of 12 mm to 16 mm, and the thickness is around 0.3 to 0.6 mm. Okay, this will be small steel band, and the width of this particular steel band is 12 mm to 16 mm. Okay, the width of this particular portion is 12 mm to 16 mm, and thickness of the chain is around 0.3 to 0.6 mm, and the chain is divided by brass studs at every 20 centimeters. Okay, after 20 centimeters it is going to mark up with the brass stud. Okay, and or else instead of brass studs the band chain may have graduated carving as a centimeter. Okay, and for easy usage and workability, band chains are wound on steel crosses. Okay, this is the steel cross. Okay, for easy usage and easy carrying, we are going to wound the particular total chain to this crossing. Okay, or metal rails from which they can be handled unrolled. Okay, from this we are going to fold it and we can unroll. Okay, this steel band is accessible in 20 meters to 30 meters length. Okay, the total length of this particular steel band is around 20 meters to 30 meters. Okay, and the width of this chain is around 12 to 16 mm, as mentioned before. Now coming to the next instrument we are using in the chaining is arrows. Okay, when the length of the line is to be measured is more than a chain length. Suppose if you take a metric chain, one of the examples, suppose you have taken 20 meters chain. Okay, after marking 20 meters chain, suppose if the length of the area to be measured is more than 20 meters. Okay, if that particular length is more than 20 meters, then after placing 20 meters chain to this particular place, we are going to measure the next distance. So here, while removing the chain, we are going to place one arrow here, so that that particular area will be marked, and this is the arrow we are going to use for marking the points on the ground. Okay, so arrows are used for this purpose because we are going to mark the distances or points. Okay, a typical arrow is shown in the below figure. So in this particular figure you can see the arrow. Okay, arrows are made up of 4 mm diameter. So the diameter of this particular arrow is 4 mm, and the length is around 400 mm. Okay, the length of the arrow is around 400 mm, and if you see the edges of this particular arrow, one end is looped. Okay, one end is bent like loop, and the diameter of this loop is around 50 mm. Okay, so this is what the arrow, and if you see the another end here, this is sharpened to place the arrow in the ground. Okay, this is the arrow, and next one, peg. So pegs. Okay, so wooden pegs are used in measuring the length of a line to mark the end points of the line. So while measuring the lengths, okay, while measuring the lengths from one point to another point, we are going to use a chain, and if you want to mark these end points after measuring, then we are going to use the pegs. Okay, and the pegs are made of hardwood of 25 mm square. Okay, and 150 mm long, with one end tapered as shown in the figure. See, the cross section of this particular wooden peg is around 25 mm square, and the total length will be 150 mm. Okay, and one of the other ends is sharpened like this, tapered. Okay, this is tapered to place the wooden peg on the ground. Okay, when this particular wooden peg is driven in ground to mark the station points, they project about 40 mm. Okay, if you place this particular wooden peg on the ground, the projection of this particular peg is around 40 mm. 40 mm will be projected into the ground. Okay, and you can see the image of wooden peg. Next one, ranging rods and ranging poles. Okay, so for ranging intermediate points along the line to be measured, ranging rods are used and ranging poles are used. Suppose if you want to measure a longer distances, so if you want to mark an intermediate point between these particular two distances, then we are going to use the ranging rod. By seeing this ranging rod, we are going to mark the position of the object. Okay, and ranging rods are 2 to 3 meters long and are made of hardwood or steel. So these ranging rods are made of hardwood or steel, and the length of this ranging rods is around 2 to 3 meters, and they are provided with one iron shoe at one end as shown in the figure. So if you see this particular iron rod, so here you can see the iron shoe which is provided at the top. Next one, they are usually circular in section with 30 mm dia. So these particular ranging rods will be having a diameter of 30 mm. Okay, and painted with 200 mm color bands. So this particular ranging rod, see this particular ranging rod will be painted with some colors like this, so that we can see the ranging rod clearly, and the distance, the dimensions of this particular band is around 200 mm. Okay, and if the distance is more than 200 mm, okay, if the distance is more than 200 meters, for clear visibility they may be provided with multicolored flags, okay, at the top. So if the distances are more than the 200 meters, then we are going to place a flag which is multicolored, okay, to improve the visibility of the ranging rod or else the position of the object. And the ranging rods are occasionally used to measure short distances, since they are painted with alternate colors of band 200 mm. So normally we are going to use these ranging rods for measuring the short distances. Okay, and ranging poles are similar to ranging rods. Okay, ranging rods and ranging poles are both are same, except they are very longer. Suppose if you take the dimension of the ranging poles, it is around 4 meters to 8 meters. Okay, and the diameter from 60 mm to 100 mm. Okay, the length of the ranging poles are 4 to 8 meters, and the diameter of the ranging pole is around 60 mm to 100 mm, and they are made of hardwood or steel. Okay, these ranging poles are also made of hardwood and or steel, and they are fixed in the ground by making 0.5 meters hole and then packed to keep them vertical. So we are going to place the ranging pole by making an excavation of around 0.5 meters. Okay, 0.5 meters hole is made, and in that we are going to place the ranging pole. The next one, offset rod. Okay, in the above picture only we have placed it. See, this is the offset rod. So these rods are also similar to ranging rods, and they are 3 meters long. Okay, the length of the offset rods are 3 meters, and it is also same as ranging rod. And they are made up of hardwood and are provided with the iron shoe at the end. Okay, at the top end we are going to provide the iron shoe. A hook or notch is provided at the other end. Okay, on the other end we are going to place a hook. See, you can see in this picture, this is the hook or notch. Okay, we are going to provide that notch in the offset rods. So at height of eye, two narrow slits at right angles to each other are also provided for using it for setting the right angles. So we are going to provide one slit at the height of the eye. Okay, at the height of the eye. So this particular slit is used for measuring the, or else for placing or for setting out the right angles. Now coming to the next part of instruments, laths. Okay, laths are 0.5 to 1 meter long sticks of soft wood. Okay, and they are sharpened at one end and are painted with white or light colors. Okay, they are used as intermediate points while ranging or while crossing the depressions. Okay, these laths are used as intermediate points while measuring the distances or else while crossing the depressions. Okay. And coming to the next instrument, plumb bob. Okay, a typical plumb bob is shown in this particular figure, as you can see here. And in measuring horizontal distances along sloping ground, plumb bobs are used to transfer the position to the ground. Suppose this is the ground, and if you want to transfer this particular point onto this particular ground, we are going to use the plumb bob. Okay, we are going to use the plumb bob to transfer this particular object position to the ground level. Okay, and they are also used to check the verticality of ranging poles. So suppose after placing the ranging rod or ranging pole on the ground, if you want to measure whether it is vertically placed or not, then also we are going to use this plumb bob. Okay, so these are the different instruments we are going to use in the chaining. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.